At the very edge of the world, where temperatures plunge far below freezing, a powerful force stirs beneath the ice. What appears calm and untouched is, in reality, one of the most active and unusual volcanic systems on Earth. Hidden beneath layers of snow and rock, molten magma rises steadily, feeding a fiery core that refuses to go quiet. At its summit, a rare and persistent lava lake churns continuously, releasing gas and triggering sudden bursts of explosive activity. This volcano's behavior is unpredictable, its hazards constant, and its location unforgiving. In a place where survival is already a challenge, this restless system adds another layer of danger, one that scientists are only beginning to fully understand. Rising from the frozen silence of Antarctica, Mount Erebus stands as one of the most surreal and extreme volcanoes on Earth. Located on Ross Island, Erebus is the southernmost active volcano on the planet, towering 3,794 meters above sea level. To the untrained eye, it appears almost lifeless, a dark, snow-covered peak in a vast white wilderness. But beneath that stillness lies a system that is very much alive. Mount Erebus is not just another stratovolcano. It is part of the West Antarctic Rift System, a vast geological region where the Earth's crust is slowly pulling apart. This tectonic setting allows magma to rise more easily from deep within the mantle, feeding Erebus with a steady supply of molten material. What truly sets Erebus apart is the presence of a long-lived lava lake within its summit crater, a feature so rare that only a handful of volcanoes on Earth possess one. Unlike the more common basaltic lava found in places like Hawaii, Erebus produces phonolite magma. This type of magma is thicker, richer in gases, and more prone to explosive behavior. It does not flow as easily, and when gas pressure builds within it, the results can be sudden and violent. The lava lake at the summit is not static. It churns, circulates, and releases gas continuously. Large gas bubbles rise through the molten surface and burst at the top, creating small but powerful explosions known as strombolian eruptions. These events can hurl molten rock high into the air, sometimes without warning. Before we continue, don't forget to click on that subscribe button and like this video, as it's the best way to support this channel. One of the most fascinating and lesser-known features of Mount Erebus lies not in its crater, but beneath its surface. The volcano is riddled with ice caves formed by the interaction of volcanic heat and Antarctic ice. These caves are created when hot gases rise through cracks in the rock, melting the surrounding ice and carving out hidden chambers. Inside these caves, the environment is unlike anything else on Earth. Warm air from fumaroles keeps temperatures far higher than the surrounding surface, sometimes even above freezing. The walls glisten with ice crystals, and steam drifts through the tunnels, creating an otherworldly atmosphere. These caves are not just geological curiosities, they are also biological laboratories. Scientists have discovered microbial life forms living within them, organisms that survive in conditions of darkness, isolation, and extreme temperature gradients. These findings have sparked interest in the possibility of life in similar environments on other planets, particularly Mars. But the caves are also dangerous. They can be unstable, with ceilings that collapse without warning. Toxic gases can accumulate in enclosed spaces, creating invisible hazards, and navigating them requires traversing a landscape filled with hidden crevasses and fragile ice structures. Although Mount Erebus does not produce the massive, catastrophic eruptions associated with supervolcanoes, it is far from gentle. Its activity is characterized by frequent smaller explosions, driven by the release of gas from the lava lake. These strombolian eruptions can occur with little to no warning. For scientists working near the summit, these events represent a constant threat. Even with monitoring equipment and safety protocols, predicting the exact timing and intensity of an eruption is extremely difficult. The danger is not limited to direct impact. Falling lava bombs can destabilize the surrounding ice, triggering collapses or avalanches. In such an environment, even a relatively small eruption can set off a chain of hazardous events. Beyond the visible hazards of lava and explosions, lies a more insidious danger. Mount Erebus continuously emits volcanic gases, including sulfur dioxide and carbon dioxide. These gases are released from the lava lake and from fumaroles scattered across the volcano's surface. In open areas, these gases can dissipate quickly, but in low-lying regions, caves, or areas with little wind, they can accumulate to dangerous levels. Carbon dioxide is heavier than air and can settle in depressions, creating invisible pockets that can suffocate anyone who enters them. And because these gases are often odorless or difficult to detect without specialized equipment, they can pose a deadly threat before anyone realizes what is happening. Perhaps the greatest danger associated with Mount Erebus is not the volcano itself, but its location. Antarctica is the most remote and inhospitable continent on Earth. Temperatures can plunge below -40 degrees Celsius, and powerful storms can arise with little warning. The nearest major research facility is McMurdo Station, but even this outpost is isolated by global standards. Reaching Erebus requires careful planning, specialized equipment, and favorable weather conditions. Once there, evacuation options are extremely limited. If an accident occurs, whether from a volcanic event, exposure, or injury, help may be hours or even days away. Communication can be disrupted by weather, and rescue operations are often constrained by the same harsh conditions that create the emergency in the first place. This isolation transforms even minor incidents into potentially life-threatening situations. The dangers of Mount Erebus have been demonstrated in one of the most tragic aviation disasters in Antarctic history, the Air New Zealand Flight 901 disaster. In 1979, a sightseeing flight carrying 257 passengers and crew flew into the slopes of Erebus during a whiteout. The conditions made it nearly impossible for the pilots to distinguish the horizon from the snow-covered terrain. As a result, the aircraft descended directly into the mountain. There were no survivors. This event serves as a stark reminder of how dangerous this volcano and its surrounding environment can be. Mount Erebus is not considered a supervolcano, and it is unlikely to produce a global catastrophe. However, this does not mean it is harmless. Its persistent activity, combined with its unique magma composition, means that it will continue to pose risks for as long as it remains active. Changes in the behavior of the lava lake, shifts in gas emissions, or variations in seismic activity could all alter the level of danger associated with the volcano. Scientists continue to monitor these factors closely, using Erebus as a natural laboratory for understanding volcanic systems. There is also the broader context of climate change. As Antarctic ice conditions evolve, the interaction between ice and volcanic activity could change in ways that are not yet fully understood. Melting ice could alter pressure on the volcanic system, potentially influencing its behavior. While these possibilities remain uncertain, they highlight the importance of continued research and observation. The future of this Antarctic volcano is not defined by a single catastrophic eruption, but by the steady continuation of a system that is already active. Unlike dormant volcanoes that build toward rare, explosive events, this one operates in a near-constant state of unrest. Its lava lake continues to circulate, gas emissions persist, and small explosive bursts remain a regular occurrence. In many ways, the danger is not something that may happen, it is something that is already happening. However, subtle changes in the system could alter its behavior. Variations in magma supply, shifts in gas pressure, or changes in the structure of the lava lake could increase the frequency or intensity of eruptions. Even small escalations could significantly raise the risk for researchers working nearby. The challenge lies in detecting these changes early enough to respond. There is also growing interest in how environmental shifts may influence volcanic activity. As Antarctic conditions evolve, interactions between ice and heat could change in unpredictable ways. For now, the volcano remains a closely monitored natural laboratory, but one that demands constant attention because its future, while not globally catastrophic, is far from stable.